Welcome to G Fun Facts Online. Today, we're diving deep into a world that's mostly invisible, but packed with organisms that could literally help save our planet. Imagine life not just surviving, but thriving, in places you'd think are totally uninhabitable, boiling hot springs, lakes saltier than the Dead Sea, or even in pools of corrosive acid. Sounds like science fiction, right? Well, meet the extremophiles. These are nature's ultimate survivors. And the coolest part? These tiny titans aren't just tough. They're actively helping us clean up some of our biggest environmental messes. We're talking about bioremediation, but with a super-powered microscopic twist. Extremophiles, these amazing microorganisms, have a knack for living where most life forms would wave a tiny white flag. They can tolerate and, even more impressively, transform pollutants under the harshest conditions imaginable. Think scorching temperatures, crazy pH levels, extreme salinity, and high concentrations of toxic stuff. This makes them invaluable tools for cleaning up contaminated sites, where other methods just can't cut it. And get this, thanks to incredible advances in genomics and something called metabolic engineering, we're unlocking even more of their astonishing potential for advanced bioremediation solutions. So how diverse are these extremophiles? Amazingly so. They've evolved unique metabolic pathways and special enzymes known as extremozymes that let them break down or neutralize a whole buffet of contaminants. We're talking heavy metals, nasty organic compounds, radioactive materials, and yes, even plastics. Let's meet a few of these microbial superheroes. First up, the thermophiles, like Thermus aquaticus and Geobacillus styrothermophilus. These heat lovers can degrade organic pollutants in superhot industrial waste. Think of them as tiny incinerators, but way more sophisticated. Then there are the halophiles, such as Halomonas and Halobacterium species. These salt specialists are brilliant for managing waste in saline environments, which is super important for industries like oil extraction. For example, Halomonas smyrnensis can reduce harmful hexavalent chromium even in really salty water. Got acidic environments like those around old mines? Call in the acidophiles. Microbes like Ferroplasma acidarmanus and Acidithiobacillus ferrooxidans are pros at tackling metal contaminants in highly acidic conditions. On the flip side, we have alkaliphiles, such as Alkaligenes and Bacillus alkalophilus. These thrive in alkaline conditions, common in various industrial processes, and they're great at treating pollutants found there. And don't forget the psychrophiles, the cold-loving microbes like Pseudomonas psychrophylla and Psychrobacter species. These guys are essential for bioremediation in freezing environments, like the Arctic or Antarctic. So how do we even find these incredible microbes and figure out their secrets? That's where cutting-edge science comes in, specifically genomics and what scientists call omics technologies. This includes metagenomics, proteomics, and metabolomics. It's like giving scientists a set of super goggles to peer into the hidden world of these extremophiles. With these tools, researchers can identify and characterize totally new extremophiles and their unique abilities from previously unexplored extreme places, like deep-sea hydrothermal vents or the icy landscapes of polar caps. They can uncover the genetic blueprints behind their amazing stress tolerance and pollutant-degrading powers. They can even mine their genomes for novel extremozymes, those super-stable enzymes that can work under extreme industrial conditions where ordinary enzymes would just break down. Plus, these technologies help us understand complex microbial communities and how they interact in contaminated environments. This is key to developing effective teams or consortia of microbes for specific bioremediation jobs. But science doesn't stop at just understanding. Metabolic engineering takes it a step further. This allows scientists to actually modify the genetic makeup of extremophiles to boost their bioremediation capabilities. It's like giving these microbes a performance upgrade. They can optimize existing metabolic pathways to make pollutant degradation faster and more efficient. They can introduce new genetic pathways, essentially teaching the microbes to break down pollutants they couldn't naturally handle before. They can even improve the organism's tolerance to even more extreme conditions or higher concentrations of pollutants. And here's a really exciting prospect. developing them as microfactories. Imagine microbes that not only clean up pollution, but also convert that waste into valuable bioproducts like biofuels, bioplastics, and biochemicals. This is a huge step towards a circular bioeconomy. Advanced techniques with fancy names like multivariate modular metabolic engineering, or MMME, and multiplex automated genome engineering, or MAGE, are being used to fine-tune the metabolism of these extremophiles for specific jobs. Synthetic biology tools are also becoming more adaptable for these unique organisms, making it easier to edit and modify their genomes. Now, it's not all a walk in the park. There are challenges. Many extremophiles are notoriously difficult to grow in laboratory settings. Their metabolic pathways can be incredibly complex and aren't always fully understood. Optimizing their growth and making them workhorses for industrial applications, often under less extreme and more economically viable conditions, still requires a lot more research and development in biotechnology and synthetic biology. Despite these hurdles, the future of extremophile research in bioremediation is incredibly promising. Continued exploration of extreme environments will undoubtedly reveal new organisms and novel biochemical pathways we haven't even dreamed of. Integrating all that omics data with computational modeling will give us deeper insights into their metabolic networks. And genetic and metabolic engineering, supercharged by tools like CRISPR-Cas, will continue to enhance their bioremediation power. This will lead to more efficient, sustainable, and cost-effective solutions for tackling the environmental pollution that plagues our planet. So extremophiles are far more than just fascinating biological oddities surviving on the edge of life. They are absolutely pivotal agents in our quest for a cleaner and more sustainable planet. These tiny, tough microbes are showing us that sometimes the biggest solutions come in the smallest packages. That's all for today on G Fun Facts Online. I hope you're as fascinated by these mighty microbes as I am. Join us next time for more mind-blowing science. Thanks for listening.